Okay, guys, welcome back. Let's see. I am going to return your papers next lecture. I still need to release your grades. More or less, I am almost done. You're going to have your grades on Canvas. Please wait until the next lecture. When I return your papers, then you're going to have the opportunity to ask questions. So when you saw your grades online, do not start sending me emails. Wait for having your paper. And after you have your paper and review your paper, then you can ask me questions, no problem. Good? Okay, so today we are working with clustering. We're working with unsupervised learning. One particular case that I want to review with you about unsupervised learning and kind of clustering in a soft way is working with text, working with documents, doing text mining, understanding quotation marks, the content of a document kind of automatically. So, number one, is unsupervised. And the reason because it's unsupervised is because we do not have a label and output to compare. Imagine that you have a book, emails, the full internet, Twitter, Facebook, whatever, and you just want to know without reading kind of the categories of the information there, or what those documents are about, which are the concepts or the ideas that are more common in those documents or in those web pages or tweets or anything. Your information, the input, is going to be text, literally. It is clustering because what you want to do is to create this classification, these clusters. Now, let's put a particular name to the cluster. What we want to figure out is the topics of the documents and put together documents that are related with the same topic. It's a cluster. Now, it is not clustering, or you cannot use the same technique that we described before for one important reason. Your input is not a table like an Excel spreadsheet or a comma separated values, because your input is literally the book, the emails, a bunch of text documents, right? And we cannot really put a text document used like as a table in Excel. It's kind of not exactly something that happened directly. However, we can do something kind of that, and therefore we can use something kind of clustering to create clusters that we're going to call topics that put together these documents automatically. And that process, text mining, unsupervised learning. So why? All those things that I described before, all the things that you are going to notice, those are the uses of being able to do clustering with documents. Kind of clear, obvious, right? Now, how to do it? To be more specific, it's all about a statistical process. Just as the other models that we have reviewed, there is nothing magic. Everything is about either measures of distance, comparison of values, trying to figure out an increment or decrement for some variables, or create some probabilities of something being in some particular category. What I want to check with you, first theoretical, and then a library that helps us, is one algorithm that we can use to do text mining. And in particular, we're going to review this one. That one, something that I put for you on Canvas, the paper that describes the full process. Those are the guys, authors of the paper. That is the year of the paper. It's a 20 years old kind of algorithm. And that is the one that we're going to be using for text mining, text document classification. Big comment here. What we are going to review is called LDA. Question. By any chance, have you listened these letters before? LDA. No? Okay, that is good news and bad news. Guys, big picture. You are going to listen those letters for different reasons. There is an algorithm for classification that we are going to review later that is LDA. But for classification, the meaning of LDA, we are talking here about text mining, unsupervised learning, kind of soft clustering, and we're going to use LDA. It is not the same LDA. Clear? So be careful when you read online or the book or whatever, those letters, try to search what the author is meaning by LDA. If you're reading about supervised learning, classification, LDA is talking about the blue one. Classification, supervised learning. If you're talking about natural language processing, text mining, or soft clustering, or unsupervised learning, we're talking about the first one. That is the one that we're going to review here today. Clear? Okay, nothing about linear discriminant analysis. All about the other one. Okay, the other one. And the first question here is, what is the meaning of that LDA? Text classification, right? L. Okay. The L is all about something that exists and you are looking for. That is what we're going to do, right? We're searching for the topics of documents. For sure, the documents have some topic. We need to figure out which one, right? Second one, the second letter, maybe the important one that is different from the other. The second one is the name of the guy that do not create the algorithm, but is kind of very involved there. Let me be clear here. The algorithm uses a particular statistical distribution, and that statistical distribution is the one that this guy created. This guy is 1800. Nothing to do with machine learning. However, we use his name because the distribution that we're going to use to randomize some things. So it's a last name from a guy. The last one, allocation. You're familiar with allocation. You work with memory allocation. In this case, what we're going to allocate is those topics that we are searching for. Makes sense? Searching for topics, latent topics that are there. We are sure that are there, but we're going to search which they are. Now, in order to work, the assumptions here are the following. This idea of searching topics for documents is working as follows. There is a big assumption here. There are some limitations here. You have a document. Those documents have words. The assumption that we are going to have is that every single word in a document can be mapped to a particular category, to a particular topic. If every single word can be mapped to a particular topic, then the assumption is that your document is not a combination of words, but a combination of topics, because every single word in the document is about a particular topic. The topic for the document is going to be the topic that you have the most according with the words that you have there. Make sense? Okay, but that is a big assumption. What about the words that are not related with topics? Because there are going to be words like that. What we're going to do is to eliminate those words. Okay, wait. What about those words that are a very high indicative of the topic? Like, you know, the title of the document is exam. We are going to also eliminate those words. So if the word is too generic, and or what is the topic for that? Delete. If the topic is more obvious, the word is pointing to a particular topic, very, very high probability, very noticeable, like an exam, keyword, delete. Keep the words that are in this middle ground. We're going to assume, for this approach, assume that you do a pre-processing of your documents, or we're going to do a pre-processing before creating the model. And that pre-processing is going to include eliminate words that we know are too obvious or do not contribute to the topics. All the words that we're going to use should have that structure. All of them belong to a topic. My document, the words that I am going to use in the document have that correlation. But another big thing here, this algorithm in particular do not care about the order of the words. This algorithm in particular, we're doing clustering, right? We do not care about verb, adjective, noun, subject, predicate. This is not about semantic or grammatical analysis. This is just about a bunch of elements, and I want to put them in particular categories. And those elements, just like the dots that we had before for clustering, now these dots are the bunch of words that I have inside of a document. And you can think about a document like a bag with a lot of words inside. The order, we do not care. It's a verb, it's an article, an adjective, it's part of the previous sentence, it's a different paragraph. We do not care. Clear? Professor, but it is very important to have that knowledge. I mean, just imagine, it's not the same the noun that use a consequence, or the verb is more important. Yeah, there are other approaches that consider that, but this approach is not about that. Good? Easy. Now, our model, to put this in simple terms, is going to be just like that. According with the previous picture, you can imagine that your data structures to work is going to be like the following. Number one, I have a bunch of documents. How many topics I am searching for? I give you all my emails or all the transcript from all the lectures, your emails, your notes in all your classes, whatever, text. How many topics do you want to identify? Do you remember k-means? The first algorithm that we reviewed for clustering, right? Remember that the value for key was something that you need to figure out. You need to figure out, literally, you put a number and see what happens. For the documents, for this algorithm, you put the number and see what happens. The number of topics is going to be that letter key. How many topics are we searching for in my email? How many topics are we searching for in your notes? is going to be a value key you decide. You are going to tell the algorithm how many topics to search for, how many classification you want to do. Looks good, right? I mean, email, good emails and bad emails. Give me two categories, and let's see if you can identify one from the other. Lectures, good lectures, bad lectures, exams, informative ones, important one for the exam, not important one for the exam. I don't know. Key. You are going to have a group of topics, and your goal, literally, is you have documents, and you want to know each document to which topic or topics that document belong. That table at the top is what you are looking for as a result. Document, topics. Why? Because then, if you can have that one, then I can ask you, hey, for the topic one, can you tell me the centroid for the topic one? And what is the centroid or the equivalent to the centroid? Give me the words that are more important for a document to be considered part of that topic. I can give you all the words. I can give you all the documents that belong to that topic, but maybe something that you're looking for is give me the key ideas. That is the closest thing to the centroid that you have in the k-means, right? Okay, now, in order to achieve that, what we are going to do is the following. Your input, your documents, they have words. And literally, for every single document, you are going to read all the words. Each word is going to become kind of this idea of a column. And you are going to put, okay, in this document, I have this word. And that word, if that appears in another document, is not going to be a new column. You are just going to add a one in that particular space, document 2, this column. Are you telling me that we're going to read all our text files, documents, and we're going to search for all the different words in all those documents? Yes. Can you do that? Is an reader in Java is to split words. You know patterns, or you know some kind of tokenizer things. You did a tokenizer, a lexical analyzer in some class. For every single word, you can search that word in a data structure. If the word do not exist, insert. I am sure that you have done that thing before. Search for a duplicate, exists, okay, forget about it, or increase the counter, do not exist, insert, and put one in the counter. It's a very trivial problem for computer science, right? Professor, but it's going to be too slow. I mean, what you are asking is a loop and a linked list and so on. It's going to be slow. Yes, it's going to be slow. Good news. What do you do if you have a process that is basically loops and conditions that is slow? Multi-threading. This is the first time that when we review the source code, I am going to point out an instruction in which literally you're creating threads. Why? Because this is a process that will be very, very slow if you follow sequential. However, multi-threading, you can have a Lexer analyzer multi-threading, and you do this counting of the words in different documents, and you create a data structure that have that information. Clear? Moreover, yes.
Can a word belong to the specific topic, or it can belong to multiple topics?
I am going to speak about that exactly. Now, number one, I have my documents, I have my words, and I'm going to have this kind of matrix, words by document. A document is a combination of words. Now, the next thing, I need to know for each word, what is the topic that corresponds. And one word or one topic can have different words. One word can have different topics. It's used once. Topic one, K1. For the topic one, I have this word, this word, this word, this word. Okay, this word one belong to the topic 2, to the topic 3, to the topic 4, and 6. Make sense? Wait, it's not so easy. We are going to move to the critical part. But so far, documents, words. Topics, words. And at the end, we do the mixture about document with topics. That is what we are looking for. Did you notice? Now, what I am showing you there is use zeros and ones. Zeros and ones. Yes or no? Zeros or ones. The word is part of the topic or not? Zeros and ones. The topic is part of the document or not, or the document, the word of the document, or whatever. The tricky part here is, yes, those are our data structures. But now think about the following. It's not about zeros or ones, but the key idea here is each of those zeros or each of those ones is going to be a probability. So it's not going to be a zero, could be a zero. It's not going to be a one, could be a one, but it's going to be a number in between. So what I need to do is, what is the probability of this word to belong to the topic 1, to the topic 2? And yes, that word can be in both topics, but the probabilities could be the same or different, hopefully different. The document in a particular topic, what I am going to have is put together the probabilities of all the different words, and basically I'm going to figure out the probability of one document, the full document, to belong to a particular topic. But also I am going to figure out the probabilities of that same document to belong to other topics. What I am going to have is what you have in the neural net, the second one that we create with softmax and so on, like a report of probabilities. Obviously, what you're looking for is the highest probability. The highest probability is the one that you can use as a topic for the document. But what you get is probabilities for all the different topics that you create, that you ask for in your case. Makes sense? Okay, now, good. Let's see. If you are going to run this table, words per document, is something that you can calculate. You have your documents. Can you create a table like the first one? Which words are in your document? How many times the word is in your documents? The numbers here, these do not need to be probabilities. These are going to be real data because it's something that you can count, calculate, right? Good. So this is the easy part. Second, at the top, document and topics. Help me. I want to create 6 topics, and I have these 5 documents. What is going to be the values inside of that table at the beginning? Unsupervised learning, remember? I give you all my emails or my transcript from the lectures, and I ask you, guys, found 6 topics in those documents. Which are the topics for my documents? Which information you put in that table in the second column? Do you have the information? Yes or no? The topics for my documents? You do not know. That is what I am asking you to search for. So, but I need to initialize those columns. I need to put some values there. What do we do with those values? Now you know, right? Neural nets, random values at the beginning, clustering, random values for the center, text, document topics. You want 6 topics? Randomly, probabilities for the document 1 to belong to the topic 1, topic 2, topic 3, topic 4, topic 6. Give me random numbers and we put that as a probability. Done. Really? Yeah, we need to start some way. Put probabilities random there for the document to belong to the different topics. Okay, what about the second table? Topics that you asked me for 6, but you could ask me for 5, 3, 4, or more, Remember this number, the value for K is something that you tell me, and all your words. Words. The number of words come from the document, right? These columns here are as many columns as words, different words do I found in the documents. These topics here is a number that you mentioned. What about the values inside? Can you tell me which word belongs to which topic? The answer is no. Why not? Because you have no idea what the topic is about. This is unsupervised. I am asking you for 6 categories, 3 categories, 2 categories. You have no idea which one are going to be those categories. So what are you going to do with the relationship between those categories of the words? Random values again. So randomly, the documents belong to a category. Randomly, the words belong to a category too. At the beginning, yes. And what we are going to do is start training the model. Training the model. You start with these random probabilities, and with them, you calculate your result with the input. You are going to find an error, and you calculate new probabilities in the table 2 and 3 in order to improve that error, or to minimize that error. And you continue doing that again and again and again and again and again and again and again until there is no difference between the previous model and the new one. So again, start with random numbers and then follow a process that changes those numbers to something that makes sense. Yep. Really? Yeah, really, but let's put this in a mathematical way. The mathematical background, and here is where our friend D is going to enter, is what you have is a group of documents, and that group of documents is a collection of documents, one, and each document has words. So word is one variable. Each word, let's call it W, is a variable in the equation. Yeah. And then what you have is this idea of each word need to be connected with a topic. Okay? I need to calculate this function of word connected with the topic. But moreover, each topic of one word, at the end, you need to calculate the topic for the full document. That is going to be a function of the topics of the words in the document. And I am pretty sure that you can visualize right now that we are talking about an equation that is going to have something like this. The function that gives me the topics for each W, what I need to do is to put that together to get the function that gives me the topics for the full document. And as usual, in any equation, we are going to have this one constant that multiply the equation and help us to make that equation move faster or slower. Do you remember the learning rate in the neural nets, right? Constant number one for this algorithm. We're going to have this guy here, alpha. And this alpha is going to be a constant that is going to be applied to this function of the probabilities for the document is the collection of the probabilities for each of the words in the document. Okay, what else? However, for each of the words, you have a topic. And that topic that you have for the word is the topic that you're going to use to calculate this. Because remember, the topics for the word are independent of the topic for the document. The topic for the document is decided according with the words in the document and the topics that you have for that word. The topic for the word is another function. And moreover, for that other function, there is also a constant that is going to help us to increase or decrease, to speed or slow the result of the function. And that constant is going to be a beta. Learning rate in other models here, the imagination was kind of simple, alpha and beta, A and B. A and B, and I have these two equations, and literally what I need to do is to figure out both of them, the topics per word, and with that, the topics for documents separate. Can you put that together in a program? Yes. I need you to remember the following. Number one, remember, there are words that we're ignoring, words that are hard to classify. Number two, any word that is more than 80% of the document, any word that have a high rate of appearance is going to be eliminated also. So words that are hard to classify, words that are there a lot, remove. Those words are going to make the algorithm to fail. Second, the number of topics, this K is something that you define, not the algorithm. And moreover, the order of the words, the grammar, we do not care about. With those limitations, the algorithm that is implemented and you do not need to worry about is something like this. Guys, depending on how familiar you are with probabilities, don't worry, you do not need to be. But the point is, this algorithm is literally a for loop inside of a for loop. A for loop per document. As many documents as I give you, you're going to do something with that document. And what we're going to do with that document, the second for loop, is you are going to work word by word. You're going to have this for loop reading the words. We already defined that. And what you're going to do, 1, 2, 3 equations. Probability for, you have the word, right? Tell me the probability of this word becoming to a particular topic. Remember, you already start with random numbers. What you need to do is, now I have the word, now I need to check, hey, this word really impact a particular topic, yes or no? If yes, if not, let's update the probability measure for that word in the topic. Now, this is one. Number two, if you update the word in the topic, now update the topic for the document. Remember that they are connected, right? Word, topic, word, document, update, update. These probabilities cross it. The last one, this equation, this update. And again, the only thing that I want you to notice is this, the first one, this, the second one, a multiplication here. You update 2, and these 2, you need to put them together in order to make the connection document to topic. This put together is 2 equations in one. You update 1, you update 2, and you update the connection between these 2. You update one table, second table, one time with one word, a second time with the next word, another time with another word, another time with another word, and you continue for every single word in the document. And notice, it's going to happen that the word that you use here, in some point in the future, you are going to use it again. Because the same word can be several times in the document, in the same document, or in different documents. Each word is going to impact the model more than one time. Moreover, the words that are more frequent in the document, one, or in the documents in general, they are going to have a higher impact in how do you update the model. And that is fine, because that word maybe is very relevant for whatever topics I am trying to found. Key ideas, words, document, topics, key, the number of topics, something that you define. Now, I need to do this, and the only reason for you to solve this is two loops. Complexity, good one or bad one? Very problematic, right? N2 is not something that you want to have. But I am not talking about the data structures that you can use to improve this to make n log n or something crazy, but it's not exactly good. Again, it's going to be the performance an issue, but we need to use threads. We can use threads, and that is going to help us a lot, even with that N2. Good news is not an N3, so still the threads can improve this. So don't worry. What we need is a tool to do this. I mean, you have two options. Number one, we start learning probabilities, and we learn how to implement a program that do those things, and then read the data and so on. Or we just look for a library, and I am sure, hopefully, that you prefer the library. So, libraries, tools. Let me be clear, something that I want you to remember. Those are libraries, tools that you can use for natural language processing. Natural language processing is use the big picture for text mining. Or what? Text mining is kind of the lowest level of natural language processing. It's like the kindergarten for the full topic, right? We are checking for something very simple. Anyway, libraries for natural language processing, libraries that we can use. And from that list, I need to select one. Again, your homework, something that you can do, you can learn more. Here, I want to present one. Why? Because I want to add you for homework. I want to add you to do something. Which one I select? The best one? No, the easy for you to learn. The easy to learn? Yes, the easy one for learning. Why? Because what I want you is to check this in a practical way. I do not care about the performance. There are better libraries. There are libraries that are more common. All of these are good libraries. Let me start with that. All of them are good. The only thing is, I am not selecting the core NLP. Which one are you selecting? The one in the middle. Very fancy, powerful. A little bit more complicated to use because the libraries that you need to use and some of the notation that you need to follow. The middle one, still a powerful one. The notation is very simple. Okay, that one is the one that I select. Good. So, mallet. Mallet, machine learning for language. Good. Very descriptive name. 2002, humans. Really, the university created a library? Yes, it's a library from a university project, a graduate project. Well. The library, a Java library. What can you do with the library? All the things that I described above. The only thing that we're going to do here, clustering, especially topic modeling. We're looking for topics in documents. So the library can do several different things. Let's explore one. The topics. And if we're going to use this library, step number one for you, get the library, right? Get the library. For sure, it's going to be in the humans website. Yeah. In the human website, in the computer science department. So you go there and you can get the library. Yes, they are using PHP for the web page. Click, you enter in a web page. The web page, you have a link. You can get the library version 2.0 or something is the latest one. You get the library. You are going to get the library And because this is a university project, you are going to get the source code for the library. Yeah, you can play with the source code if you want, but honestly, get a zip file, unzip, search for a particular folder. And what are you going to have inside? Jar files. And what do you do with your jar files, including your project, and you can start working with the library. Clear, right? Jar files. How many? Those two. Two files to your project. Done. You can start working. I am going to assume, again, like I have done before with all the other libraries, that you know what to do in order to include those jars as a dependencies in your project. So you get those guys, you put in your project, and we're ready to go, right? Okay, ready to go. Step number 1. What is the first thing that we need to do in order to start working with this text classification in topics? Can you agree with me? The first thing that we need to do is to read the files. Well, before that, we need to know which files we're going to read. What do you think about a file iterator? Hopefully at this point, you understand what is an iterator. It's a pattern. Moreover, it's an iterator for files, because basically what we're going to do is to read several files. So a file iterator is something that makes sense. That class, FileIterator, exists part of the library. The library, the full package, CC, mallet, FileIterator, FileIterator. We have several iterators, yes, but the one that we're going to use is the one for files. Good. FileIterator. If you're going to create a FileIterator object, like with the instruction that I put in yellow, what do you think are the parameters that you need to pass? I think one parameter is mandatory, and there are others that maybe could be optional. I am giving you there kind of the full list, the worst case scenario, but let's start for the one parameter that is mandatory. One parameter, mandatory for the FileIterator. The what? A path. A path for what? A directory. The directory that have what? All the files. Moreover, a directory that could have files or folders with files. You give me the path of the root, and what the FileIterator is going to do is to go down to subfolders and subfolders in the subfolder and so on until I have all the files from this point down. Makes sense, right? So one path. Now, two options. For the first parameter, what if I told you my class is FileIterator? One parameter. What if I told you that the first parameter can be this, or the first parameter can be this? Do we understand the difference? What is the first one and what is the second one? The first one is a path. Remember that in Java, a path is something that you pass in a class file, but it's not necessarily a file. Could be a folder, but the class is file. It have a path, right? Now, the constructor can receive one path, that is one directory, and from that directory go down, or it can receive an array of paths. Why? Yes, because what if I have some files in the folder user something, and I have other files in my folder temporal something or whatever different place in the disk, something, or even different sources. You can pass as a parameter one folder and assume that all the data is inside of that folder, or you can pass as many paths as you need, and the program is going to search here down, here down, here down, up to you. Clear? Okay, the first one is good enough. The second one is just a fancy version. Second, you could use a second parameter in which you tell me which files you want me to read. Because what happens if you have a folder or you have several folders and you have there pictures, GIFs, JPG, whatever, and also text files. You do not want me to read your pictures. You can clean your folder by yourself manually, like remove everything that is not a text document from that source, or you can just give me a filter. A filter, basically an object that is going to tell me which extensions to read, and that is good enough. You do not need to remove anything from your files. I am going to assume the examples that I'm going to show you that because we are doing text mining, my documents are text files .txt. But you can change that. If you are using emails, maybe your emails are not txt, the extension could be another one, even though they are text files. Good. Okay, the last one, another fancy. What if in your documents you have the possibility to give me the class label? Remember, we're working with cluster. Remember, we do not know the labels. However, remember, we review k-means and we use the iris dataset in which we have the results and other datasets in which we have the results. And if we have the results, the labels, we can use that to check if our model is working or not, right? Again, it is not mandatory to have it, but if by any chance you have it, give me the information and maybe myself at the library can use that to tell you how good or how bad is your model. Make sense? So if by any chance you have those labels, parameter number 3, you can tell me where those labels are. Usually, the labels are going to be the names of a particular folder. Exams, the good ones and the bad ones. All the documents that correspond to the good ones are in a folder good. All the documents that are the bad ones are in a folder bad. And I can ask the library to use good or bad as the labels, the classes, the folder in which the documents are. Mandatory? No. This is unsupervised, but it's an option that you have. Clear. I am going to show you the example. Yeah.
So after calculating the folders, there is a different variant folders. Is that also?
Yeah. Good. Okay. So iterations of the file. We need data. Later, I am going to ask you to use particular data from yourself or something that I share. Let's start with something standard, a data set that you can get here. BBC News. Guys, I am asking you to work with common data set that exists online because two things. Number one, you can get familiar with data sets that other people are using and names that now you remember and that someone later can mention to you. Like if someone mentioned in the future, the iris dataset, yeah, that dataset with 150 elements. So you are familiar with that. But we're going to work also with your own data. It's not mandatory that you use this. So let's start with the simple example, maybe BBC News. And this data is data that you can use for classification, but we're going to use it for this topic discrimination. So this data is like the iris data set in which I already have the categories. And the categories are those 5 categories. These are news from the BBC in those 5 different categories, documents. documents from each category. Think about this. You go to the web page and basically you save documents in those categories. And what we want to do is to check if I can create a program that automatically detects the same categories that I already know that exist. Again, it's an exercise to check if this works. In the real case scenario, you do not have the categories because this should be unsupervised, right? So that said, 2,225 documents from those dates in 5 categories. You click here, literally what you're going to get is a zip file. You unzip, literally what you're going to have is 5 folders, and each folder has several documents in that particular category. Good? Documents, words, a lot. And what we do with that? Let's start programming. Programming, step number 1. And let's see if we understand what is happening. I have 2 classes. Version number 1 of my program. Only the first class at the top is using the library that I am describing, right? What I am doing, let's see. FileIterator. That is what I want to create. A more fancy version. 1, 2, 3 parameters. Remember? It's the worst case scenario. 3 parameters. 3 parameters. Do you remember the last one? The label. The label. FileIterator. Name of the class. Last directory. A constant. What do you think is this constant? For this document, the last directory, for the documents inside, for the documents inside, I am telling you, the last directory, the folder in which the document is, the last one, because there are going to be a lot before, that is the name of the class. Use those as the name of the class. So here, I am asking you to identify these 5 classes. Moreover, what I am asking you to do is, instead of giving me class 0, 1, 2, 3, and 4, identify classes, business, entertainment, politics, sport, and so on. Guys, I am just asking to identify those 5 classes or categories. The documents, I am going to use all the documents to try to figure out all the classes. This is not about only the documents inside of the folder entertainment are going to be used for the entertainment training. No, that is not the case. Make sense? The only thing that I am telling is those folders are the names of the classes that I want you to identify. But the documents, all of them go for everything. We do not make a difference about the topic per document. The previous one, the second parameter. Do you remember what was the second parameter? A filter about the documents to use, right? Let me be clear. That filter is nothing related with the library, machine learning, whatever. I want you to notice what I am using here, the filter, yeah, it's a file filter. And this file filter is something that you have in Java, IO library, working with files, implement an interface, create your own class, override a method, and the method is going to define which extensions are valid for that particular type. And with, this is a pattern, right? A lexical analyzer. Any file that ends with .txt is going to be what I consider there as one of the files that I'm going to use. Again, just because I want to have other files in these folders. These folders, the data set that you're going to get, the only thing that you have is those files. So literally, you can remove the filter and nothing is going to happen. But if you have more things, filters from Java, period. Now, number 1, finally, what is directories? an array of files, directories, an array of files with only one element, and the one element is my folder data. That seems to be data, BBC, my folder. So the file iterator. Can we do a file iterator without all those fancy, crazy things? Yes. Tell me, what could be one parameter file iterator there? Can I do something like forget about this array that only have one element and just send one of these? Can I do something like file iterator, iterator equal new file iterator, parentheses, new file, parentheses, the string, parentheses, and then use parentheses? And it's like, yes. Okay, what about if I want to use that, only one folder, comma, and well, I already have new text file filter. Only one folder, and I want to use the filter using case. 2 parameters. Yes, you can. Clear. What I do with the file iterator? Once you have the object, the next thing is you can use it, right? Use the file iterator. Can you tell me what this source code can do? If you copy, paste, compile, and run this source code, assuming that you have the data set there, what is going to be printed on the screen?
File names.
File names. Which ones? These ones? The ones inside of this one, the one inside of this one, the ones inside, all the file names. Doesn't matter which folder they are. Clear for everyone. It doesn't matter where the file is. All these folders are used for organization purposes, but at the end, the file iterator, what it's going to show you here is all the names of all the files. That is what you have. Oh, that is good. Now, next. I have the files. Something is going to happen with them. Next. For the first time, we need to talk about preprocessing of the data. Why? Because for the first time, well, you already did some preprocessing with the Irish data set. Remember the names of the categories, you should change to 0, 1, and 2. You already are kind of familiar with this idea of the data is not always perfect, not only numbers, you need to do something manually. But so far, I have been trusting you to do it manually, not about implementing something in the source code. For the first time, the library is worried about the data preprocessing, because as you can imagine, this idea of reading text files is kind of risky. Okay, preprocessing. Something that the library is going to help me to do is the preprocessing of the data. The preprocessing of the data is going to happen in the library following a particular way to do this preprocessing. For the preprocessing, we're going to use a pattern. In particular, we're going to use a pattern pipeline. We are going to create pipelines. Now, talking about pipelines, the pipeline pattern is a modification of the chain of responsibilities pattern. And we are supposed to be familiar with at least one of them. Because if we're familiar, then the source code is going to look familiar. So help me. For sure, you remember, hopefully, the chain of responsibilities. Do you remember how the chain of responsibilities look like? Do you remember that you have this one object, and then you add a handler, and add another handler, and add another handler? Do you remember that add handler thing? One thing that happened with the chain of responsibilities is every time that you add a handler, what you have is this one object connected with another, connected with another, connected with another, connected with another. All of them have a common method. And basically, when I need to do something, I call this object, but he is going to call the other, and the other is going to call the other, and the other is going to call the other, right? Chain of responsibilities. If I have these several objects connected, how many of them are going to work? Chain of responsibility is one, remember? I am going to ask him, but there is going to be a condition here. And basically, he is going to change like, it is my responsibility, yes or no. If yes, it's going to return to me, and the others never know about it. If not, it's going to pass the request to the other. And this one is going to do exactly the same if. If is responsibility here, is going to return the response to him and he to me. So I always communicate with one, the others never work, and so on. Only one is going to work and return the result. Pipeline. Similar approach, but everyone works. And what we call is a pipeline. Instead of handlers, pipes. Instead of chain, a line. Makes sense? What we are going to create is something that looks very similar to the chain of responsibilities. It's going to be the same. The only difference is this if condition do not exist, and is this method work, this method work, this method work, all the method work, and that's it. Clear? Okay, so the only thing that I need to explain now is, number one, as you can remember, this idea of the chain of responsibility, or this idea now of the pipelines, this idea of one object connected with another, connected with another, connected with another, you can create your own class. And that class have this connection with the following element. But that thing already exists. One object connected with another is something that by default you have in any data structure, linear data structure. Like in an array list, like an array list of pipes, in which this one is a pipe, 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 and all of them are connected because they are in the same list, and I have the first one, the head, and the others. It's the same pattern. It's a different implementation. Yeah, they are taking advantage of that structure that they already have. They didn't want to create all the structures that we defined. The behavior is the same. They are going to use the add to the list. If you remember the chain of responsibilities, we have the add handler, but we create our own connections. Here, they are reusing the add from the list, and they are going to add in each position in the list one object from the class pipe. And that class pipe is in the library, a pipeline. All the pipes are going to work. Makes sense? Now, they are going to work, but remember, our goal here is to do some kind of pre-processing of the data. What I am going to have is pipe as the parent of several different classes, strategies, that they do different kind of processing of the data. And when I put them together, all of them are going to work. All this processing of the data is going to happen. Hey, you are going to be the responsible to eliminate words that I do not need. You are going to be the responsible to checking for the numbers. You are going to be the responsible of. You are going to be the responsible of. And you can continue with the responsibilities, but every single document is going to go through all these objects in the pipeline. Good? Okay. You do not need to care about how to do the pre-processing. The only thing that you need to do is to remember the elements in the library. Elements in the library. Number one. Hopefully, it is clear what I am doing inside of the parentheses, new, and the name of the class. Creating the object in one line, so I save space. Number one, what do you think is going to do an object input to chart sequence? And the parameter for that guy is UTF-8. Do you remember that the text files have a particular chart set? Have you ever have a problem sharing a text file from your Mac to a Windows or vice versa? Have you have a problem submitting a homework in a text file to Canvas and the instructor or the TA don't being able to read your file because something is not exactly good there? The char set, right? Do you remember that in Windows you have the enter, and the enter is basically this 10 and 13, but in Mac is whatever, different char sets. Number one, what if the first thing that I do, just to be sure that this is going to work, is read character by character in the document, and every single character, be sure that that character is UTF-8, that particular char set. That could be a good idea just to avoid any kind of issue with characters. Yes? And the only thing that I need to do is to create an input, 2, char sequence, and in the parameter, I put the char set that I want to use. You are going to notice in my example, that one, UTF-8. Wait, do I need to do a for loop and read my files and the strings and do the translation for each line? The library is going to do that. The only thing that you need to do is put in the pipeline, this guy is going to transform the characters to this particular format. Done. Okay, second one. Obviously, there is no particular importance in the order. It's just pipelines, and the data is going to pass for the full pipeline. The second one, char sequence, lowercase, no parameters. What do you think is going to happen there? Kind of clear, right? It's like, you want to transform all your characters to lowercase? Yeah. We have a string to lowercase in Java. Yeah, it's going to be inside of that black box. The only thing that you need to do is to put a pipe here, and that pipe is going to be responsible to transforming everything to lowercase. Now, it is mandatory to move everything to lowercase? No, it's up to you. In your documents, the uppercase things are important. For instance, what if I ask you to analyze documents that are Java programs? Can we analyze Java programs? Yes, of course. It's text. And if I ask you for that, probably it's not a good idea to change lowercase and uppercase, because the name of the class and one object can have the same name, but with this uppercase difference. But for my news in the BBC, lowercase. This is a good one. Can you guess what this guy is going to? The first thing is like stop words. What is that? That is a good example. And, or, the. Are you speaking about all those words that have nothing to do in a document, just kind of make the document understandable for a human being, but for the computer are totally irrelevant? Yeah. Let me be clear here. Option number 1 for this class. Option number 1, you do not pass parameters except one. And basically for that one, what you are asking is to remove all the stop words that this library already have in a file. So you are asking the library, remove all the words that you already know are useless. And in that list of the words that the library already know that are useless are the and, or, they, everything. What if I have a list of words myself that I would like the computer to ignore? What do you think I can do? Or what do you think the library guys did? It's like make a lot of sense. Pass as a parameter. What is going to be the type of the parameter? New file with the path, and probably the method can create the stream itself. But I need to pass a path, just like before. And this guy, the pipe, is going to read that file, all the words there, And all that, they are going to be eliminated from my documents or ignored in my documents for the model. Makes sense? Okay, now I am going to go back with this fault here. 3 parameters that we can pass when we pass a list. Wait for the next example. The other one, maybe the most important one, the only 5 in the sequence that is something that you're going to have always for the examples. Do we understand what is this? Pattern is not a class in machine learning. It's not a class in the library mallet. Nothing. This is from Java.
Regular expression.
Regular expression in Java. By the way, did we notice that this is a regular expression? Okay, help me. What this regular expression is telling me? What is that? Let's start step by step. \, P, curly bracket, L. What is that? Regular expression. Any letter. The set of the letter, one element. This could represent A, B, C, D, any letter in the alphabet. Okay, and what is the represent? What is this and this and now this? Any number? And why I have there twice \, because you're programming with Java, right? And if you're programming with Java inside of the strings, if you want this character, you need to. Okay, this is kind of making sense. Now, looks like I have this underscore. What is the underscore? An underscore. Okay, so you have the letters, the numbers, and the underscore. And all of them, or they, square brackets. What does it mean, the square brackets in a regular expression? Any of those 3. And any of those 3 plus. Do you remember regular expression, the asterisk and the plus? The asterisk, 0 or more. In this scenario, the plus, 1 or more. 1 or more letter, 1 or more number, 1 or more underscore. Moreover, 1 or more combination of any place, any letter, any number of underscore. So if I have something like hello, or I have something like 1, 2, 3, or I have something like _3 or A_5, can you agree that all of them follow that pattern? So all of them are okay according with the pattern. And what I am going to do with the pattern, compile. Do you remember the instructions? And this guy is going to be the parameter for another pipe, child sequence to token sequence. What is going to be that? That I am going to create literally a lexical analyzer. What is going to be that? Yeah, lexical analyzer. If I have a line like hello world, what my program is going to do, that pipe there is going to do is it's going to start reading characters. All the characters are going to go down lowercase. Moreover, all of them are going to be UTF-8. And after reading a full word, in some point of the pipe, it's like that thing fulfill the pattern. Yes. Okay, you know what? Instead of using hello, right now, what you are going to do is, I have a token, a new one, token 0. Token 0 from the position 0 to the position 5. My hello, goodbye. Now is your token 0. Your token 0, your word 0. And is in that position if later we need to go back. Okay, what about word? You're going to have a problem. I put the exclamation mark, right? And with the exclamation mark, that pattern do not match. What is going to happen with my word exclamation mark? Ignore. Move to the next one. Okay, let's remove the exclamation or put a white space there, whatever. And now you're going to have token 1, and you're going to have here 6 to 9. And you can continue with that, and that is going to be your input, really. Obviously not in a text file, but in a linked list. Makes sense. Okay, guys, let me stop here. We continue with this next lecture. Thank you.